Okay, طلاب, we're going to do part C, which is y equals to 3 over x plus 2. Let's go to the black screen and let me type the question. So the white screen. So y equals, let me make sure what was the question. Okay. Three over x plus 2. So pay attention, students. So here, as you can see, it is a rational function because it is a over b. And the graph of rational function, okay, as we did in the previous video, it has a shape like this and like this, or like this and like this. It depends on the sign, okay? So for this type of function, first of all, the common sense, we have something here that deals with the common sense, is the denominator, this should not equal to 0. So you gotta find the value of x that makes the denominator equals to 0 and exclude it from your domain. So that means x plus 2, that's what you're gonna write, okay, must never, ever equal to 0. Listen to me carefully. And that's not valid for this question only. It's valid for every math question in the math books. So you're just going to do minus 2, minus 2. So in other words, x can take any value, but cannot take minus 2. Here we have identified the first vertical asymptote. So this is the x-axis and the y-axis. Look carefully, students. This is the x-axis and this is the y-axis. Okay, let me make it straight a little bit. Okay, this is the y-axis. So as you can see, we can use any value of x except minus 2. So I'm going to use the red, symbolizing, for example, the electrical line, whatever, and I'm going to do like this. Try to make a straight line at x equals to minus 2. So that means draw the graph anywhere but never get close or touch this region. Now, because the x is in the denominator, this is a reciprocal function or rational function, so the graph is going to be like this. And it is positive, so the graph is going to be like this. And from the other side, it's going to be like this. Okay, so we have the vertical asymptote, obviously, vertical dot asymptote occurs at x equals to minus 2. That's the vertical asymptote, which is the electrical line or the death line where the graph cannot touch or crosses. Remember, that's the asymptote basically. It's a line where you cannot cross or touch. That's called asymptote. So, and the other line, which is the horizontal, as you can see, the horizontal asymptote, okay, that occurs at y equals to 0. And the reason that y equals to 0, okay, if you take values for x, let me take this equation here, students, for a second. So I'm going to change the color so that you can see the difference. Let me use the red again. Okay, and let me write it here. So the function goes like this. Why? I want to explain to you why the graph, this graph, gets so close to the x-axis. Okay, look, y equals 3 over x plus 2. Here, over x. I'm not going to write x, I'm just going to write plus 2. Now, substitute instead of x a very, very big value, like trillion or billion or anything, something 10 to the power of 8, for example. Okay, that's going to make the equation or the function look like this: 3 over a very huge number, which is roughly equals to 0. So approximately, which is not equal to 0, roughly equals to 0. So the graph keeps on getting so close to the x-axis. Why? Because at this point, the value of y is so small. And the same thing if you took a negative value. Negative infinity is going to get so close to get here, to get the value of a very small, like a negative value, but very close to the origin, like this. So the graph keep on getting so close to the x-axis, but below it. So the graph of this function, let me erase the board here for a bit, or let me erase it all. Look, the graph of the function is going to look like this. Okay, this is the vertical asymptote. Okay, here in black, and this is the graph. It goes, let me extend this a little bit so that you can see it clearly, and this is the graph. So it goes like this, barely gets so close to the x-axis and goes down, and this one goes like this. Now check your graph on Desmos. Look at Desmos, it goes like this. So the question over x plus 2, like this. Let me erase it so that you see it clearly. Look, there we go. And let me graph for you here the x equals minus 2 so that you see another x equals minus 2. That's the vertical. See, look, that's the vertical. It gets so close to it but never touches it or crosses it. That's the vertical asymptote. So this is the graph of your function. Okay, now let's go to the second question, part D. So it's 3x over x minus 1. Let me copy this. So the question is decide or find x. So here y equals, let me clear it again. Also y equals 3x. Now you have x in the numerator, so pay attention, over x minus 1. First of all, before we start with anything else, look at the denominator. That's the first thing you gotta do. Make sure that the denominator does not equal to 0, never, ever. So before you do anything to any question in the world, make sure that the denominator is never equal to 0. Why? Because if it is equal to 0, it will become undefined. Sadly, we don't have an answer for this. We are in the century of the artificial intelligence and so on, but we don't have a specific answer for questions like this. Y equals 3 over 0. What is the value for y? Except we're going to say it's undefined. Anyways, so going back to our question, so the denominator must not equal to 0. So you're going to say plus 1 plus 1. That's the first part. We found the vertical asymptote. So x does not equal to 1. So if I want to graph the x-axis and the y-axis, this is x-axis. Okay. And this is the y-axis. Now I'm going to draw the asymptote. I'm going to use a blue. So this is the vertical asymptote here. So this value is at x equals to 1. So in other words, use anything but never 1. So the graph cannot take the value of 1. Now for the horizontal asymptote, because I have x in the numerator and x in the denominator, so what do? I take the coefficient of both x's and divide them by each other. So it is 3 over 1. The answer is your horizontal asymptote. Voila, this is the secret to find the horizontal asymptote. If you have x in the numerator, so x to the power of 1, and x to the power of 1, they should be the same power. Listen to me carefully. In the previous question, there was x in the denominator only, so the horizontal asymptote is always 0. But if you have x in the numerator and x in the denominator having the same power, you divide the coefficient of x in the numerator by the x in the denominator. Okay, you get the horizontal asymptote. So we have a horizontal asymptote of a value of 3. Let me change the colors like this. So these are the two electrical lines that you cannot cross, sir. So you have y equals 3. There you go. Now we gotta decide, because it's a rational function, it's gonna be either like this or like this. So how do I know which side to do? You have to substitute. Take a value greater than 1. For example, take 10 and substitute it in your function. Let me clear some of the things here. Oops. Okay, that's fine. So if you substitute the value of 10, so you're going to have 30 over 9. 30 over 9 basically, so let's say 27 to round it, so it's 3 point something. That means it's somewhere here. So if you take 10, you're going to get a value of here. That means it is going to go like this, because you got an answer in this quadrant, not here. Let me cross these out for you so that you see. So I got the value here, not here, nor here, nor here, because the asymptote becomes your x-axis and y-axis, the new ones, the new x-axis and y-axis for you. Okay, so the graph goes like this, and immediately the other graph is here. You're done. To make sure, take for example 0. So if you take 0, substitute, this is 0 over minus 1, so it is 0. So basically the graph is not like this, it's like this, and that one goes like this. Okay, let's check the graph on Desmos. If you go to Desmos, let's clean this screen and go here. So it is 3x over x minus 1. There you go. And let's remove this. And let's make this bigger so that you see it. There you go. See? So let me draw the asymptotes that I found. I said there's an asymptote at x equals 1. Remember? That's at x equals 1, as you can see. And then there's another asymptote at y equals 3. Remember? Y equals 3. That's what we get. There we go. See? These are the asymptotes. Look. The graph, you must see, the graph never touches these and never gets close. You're gonna say, oh, look, sir, look, it's touching. Well, I know that's the screen, but in reality, the line is so thin. The asymptotes and the line of the graph are so thin that they never touch each other. You see, they never. So these are the asymptotes. Okay. Okay, we'll stop here and we'll make a video for the last one.